Today's lesson, lesson 4.2, will be on writing inequalities on a number line. For more information on writing inequalities on a number line, you can refer to T.2 on IXL. For additional information on writing inequalities on a number line, you can refer to page 484 in the textbook. This is section 11.4. Now some jokes. There's some people running into the water and a shark is yelling, "Bear, bear." Because most of the time people run out of the water when they see a shark. An American staple, potato salad. It says, "When potato salad goes bad." And you can see a potato salad holding a gun. Let's begin with our daily review. Which three fractions are equivalent? Take a minute to write down these questions if you need more time. So I look at these fractions and I notice the first one I see is 1/2. So now I think I'm going to try to find fractions that are equivalent meaning the same, to 1/2. I see there's another one, 18 over 36. So if I take 18 over 36 and I write that on the side here, I will simplify that. Based off our divisibility rules, I know that if numbers end in even, both of these end in even numbers, then I can divide them by 2. So I divide the top and the bottom by 2 to get 9 over 18. Now I have 9 over 18, and I recognize that 18 is exactly half of 9. So I can divide both the top and the bottom by 9 to get 1/2. So far, I have 1/2 and 18 over 36. Let's see, I had 36 over 92. I know if I double 36, that's not going to equal 92. 17 and 35, if I double 17 and 35, that does not equal 92. So let's try 75 over 150. 75 over 150. I recognize that both of these numbers end in a 5 or a 0. I know based off of my divisibility rules that when numbers end in a 5 or a 0, I can divide them by 5. So I'll begin by dividing both of these by 5. 75 divided by 5 is 15. And 150 divided by 5 is 30. Now I ask myself if I can divide any further. I can. And I can divide 15 and 30 by 15. 15 divided by 15 is 1, and 30 divided by 15 is 2. So I get 1/2. So my three equivalent fractions are 1/2, 18 over 36, and 75 over 150. Remember, equivalent means the same. So all three of these fractions, even though they're written differently, are the same. Number 2. Solve the following equation. Equation means equals, so I know that the left side equals the right side. Once again, feel free to write down this equation if you need more time. I begin by identifying opposite operations. 2x is the same thing as multiplying, so therefore I have to divide. If I divide by 2 on the left side, I have to divide by 2 on the right side. The 2's cancel out. Next, I do 32 divided by 2. The 32 goes inside the house. 2 goes into 3 one time. 3 minus 2 is 1. I bring down my 2. Next, I see how many times 2 can go into 12, and it's 6 times. 2 times 6 is 12. And I get a remainder of 0. So x is equal to 16. You can check your answer by plugging in 16 in for x. Number 3. 5x equals 55. If you'll notice that the previous question was very similar to this one. Think about what operation has to happen here. Well, we have multiplication, so therefore we have to divide. Separating the left side from the right side, I then cross off my 5's. Now I'm left with 55 divided by 5. I know both of these numbers end in a 5, so I can divide them both by 5. So, 55 divided by 5 is 11, and 5 divided by 5 is 1. So my answer is x is equal to 11. Let's begin with the third question. If you'll notice that, like the other questions, we had an equal sign. So we can go ahead and draw a line through our equal sign. Next, we can minus 16 from both sides since we're adding. 32 minus 16 is 16. My 16's cancel out. I bring down my 2x. After that, I divide both sides by negative 2. Next, I divide 16 by negative 2 to get x is equal to negative 8. You can check your answer by plugging in negative 8 in for x. Let's go back to our learning goal. I can write inequalities on a number line. Before we begin, I want to show you a picture of a cat I fostered named Tiger. Isn't she adorable? If you could tell me the name of this cat and the fact that it's a calico, her name is Tiger and she's a calico, I'll write you a pride ticket. Let's begin with writing inequalities on a number line. What number is the problem on? Well, here it says x is less than or equal to 2. To begin, I'm going to put an open circle on 2. After that, next let's read step 2. Figure out whether the symbol has a line underneath or not. If there is a line, put a closed circle. If there's no line, write an open circle. So since there's a line underneath the inequality symbol, I'm going to fill in my circle. This means my solution is included, where x is less than or equal to 2. Step 3 says, read the problem. In this problem, x is less than or equal to 2. Less than or equal to 2. Put dots for all the numbers that are less than or equal to 2. I want you to think in your mind what a solution is for this inequality. X is less than or equal to 2. What's one possible solution for this inequality? Well, 1 is one possible solution. 0 is less than or equal to 2, so that's another solution. Negative 1 is a possible solution because it's less than or equal to less than or equal to 2. And let's do one more. Negative 2 is less than or equal to 2. Next thing we want to do is we want to connect our dots and then draw an arrow after. So looking at the number line again, we can see that all of our solutions are less than or equal to 2. Let's look at this one here. We have x is greater than 6. X is greater than 6. Let's begin by looking back at our steps. First thing we want to do is identify what number the problem is on. It's 6. Next, we want to figure out whether the symbol has a line underneath or not. There's no line. If there's a line, put a closed circle. If there's no line, put an open circle. So we'll leave it open. Step 3. Read the problem. In this problem, X is greater than 6. Put dots for all the numbers that are greater than 6. So I want to think in my mind of solutions that are greater than 6. I know 7 is greater than 6. I know 8 is greater than 6. I know 9 is greater than 6. And so is 10. Finally, we want to connect our dots and draw an arrow after. And there's our solution. I'm going to look back at the previous question and compare and contrast this question. Aside from the differences, that this is a less than or equal to problem, and this is a greater than problem, what else do you notice that are different? Well, one thing I noticed that's different is that this is an open circle and this is a closed circle. Can you think of one reason why this is a closed circle and this one's an open circle? Well, there's two reasons. The first is that this problem does not have a line underneath, so therefore it's an open circle. And this problem does have a line underneath, so therefore you should close it. Notice that all of our solutions have filled in dots. 6 is not a solution. Therefore, the dot has to stay open. In this example, 2 was a solution. And notice how all of our dots are filled in. So all of our solutions get closed dots, and all of our problems that aren't solutions get open dots. And if you don't quite understand that, just remember that if it has a line underneath, it's a closed circle. And if it doesn't have a line underneath, leave it open. Number 4. X is less than 4. I'll draw a circle on 4. Next, I'll think about solutions for this inequality. I also notice that there's no line underneath, therefore I'll leave it open. One possible solution where x is less than 4 is 3. 3 is less than 4. 2 is less than 4. And 1 is less than 4. Next, I'll connect my lines, or my dots. And there's my solution. X is less than 4. Notice how we have an open circle because there's no line underneath our inequality sign. Also remember that 4 is not a solution, so therefore the circle stays open. Let's do a few examples of where we don't have a number line. Let's begin with number 3. N is less than or equal to negative 3. I'll go ahead and draw a line. And I'll start at negative 3. Then I'm going to go 3 larger and 3 smaller. Next, I'll think about what problem or what number is in my problem. And it's negative 3. After that, I'll fill in my circle because there's a line underneath. And it's greater than or equal to, or less than or equal to. After that, I'll identify solutions for this inequality. I know that negative 3 is a solution, and that's why it gets a closed dot. One possible solution for this inequality is negative 4. negative 4 is less than negative 3. I also know negative 5 is a solution. I also know that negative 6 is a solution. Now I can connect my dots. And there you go. I've completed my graph. For this next question, I have 2 is less than x. What's different about this question than this question? Well, if you said the variable is on the right side, then you're correct. See, on this question, the variable is on the left side. So we'll begin by switching our variable to the other side. So now I have x is greater than 2. Next, I'll draw a number line. And I'll write 3 bigger and 3 smaller than 2. And you may have to continue your number line as you go. Now I identify what number my problem's on, which is 2. I recognize I have an open circle. And next I'll think about solutions for this inequality. So 3 is larger than 2, 4 is larger than 2, and 5 is larger than 2. I'll connect my arrows, or my dots, and there I go. So my solution is written here on this graph. It's important to not just say, okay, the arrow is going left, so I'm going to draw my arrow left. You should really think about what types of solutions can go in for x that make this true. It's important to not just look at the direction the arrow is going, but to think about solutions that could go in for x. For a final example, I want to show you what happens if you don't flip the inequality sign. The first thing I'm going to do is draw a number line. I'll begin by going 3 bigger and 3 smaller than 0. Next, I'll put a circle on 0. After that, I recognize there's no line underneath my 0. Now I'll begin by thinking about solutions that could go in for y. Since 0 is greater than y, I know that negative 1 is a solution, because negative 1 is less than 0. Another solution where 0 is greater than y could be negative 2. Another possible solution where 0 is greater than y is negative 3. Notice the direction the arrow is going. But if we rewrite our inequality, where y is less than 0 with the variable on the left side, you'll notice the differences between the two. Today's lesson was writing inequalities on a number line. For more information on writing inequalities on a number line, you can go to T2 on iExcel or page 484 in the textbook, section 11.4. Thank you for watching.